In this video, we're going to be solving some of the hardest math problems on the SAT step by step. Try Noble Test Prep today from the link in the description down below. More than 2,000 practice questions, challenge questions, lessons over math, reading and writing, and Desmos, a vocab section with over 200 terms, and a lot more. Like and subscribe for more like this, and let's get started. Our first problem here says if fx squared minus 12x plus 3 equals 0, and the sum of the roots of the equation is equal to k times the product of the roots, what is the value of k? So the first thing we want to do is translate what this question is actually saying. So remember that the sum of the roots is equal to negative b divided by a. Change my pen to be a little bit thicker here. And the product of the roots is equal to c divided by a. And we're told that the sum of the roots is equal to k times the product of the roots. So now, of course, that we know that the sum of the roots is negative b over a, we know that the product of the roots is c over a, we can construct our equation, which should be negative b over a is equal to k times c over a. So this is our equation, right? And so now all we have to do is extract a, b, and c from this equation up here. So 5x squared minus 12x plus 3 equals 0. Now recall the quadratic standard form, which is ax squared plus bx plus c equals 0. And then now we can easily pick out our a, b, and c in this equation and then go on from there. So it's clear to see here that our a is equal to 5, and that our b is negative 12, and that, of course, our c is 3. So if a is equal to 5, b is equal to negative 12, and c is equal to 3, now we're just going to take this equation that we wrote up here and plug in our a, our b, and our c. So this becomes positive 12 over 5 because that is a double negative, right? A negative and a negative make a positive. So whenever we plug in negative 12 for our negative b, that actually becomes positive 12. And then equal sign, and then times k. K is still unknown, so we'll just leave it as k, of course. And c is equal to 3, as we know, and then a is equal to 5. So this is what our equation now looks like. Now, there are two ways that you can go about solving this now. You can, of course, just use algebra and divide 12 over 5 by 3 over 5, and then you keep, change, flip. Or you could go into Desmos and use regression to solve for k. If that's faster to you, then you can go ahead and do that. Either way will get you the correct answer. Here, just because it's not going to save a ton of time, I'm just going to opt for the by hand solution. Since doing a regression in Desmos might not save us too much time, it's okay to just do it by hand this time. And then when we evaluate this, whenever we multiply fractions, remember we just go straight across. So it's 12 times 5 and then 5 times 3 to get our fraction. And this becomes 60 over 15 is equal to k. And then if we simplify this 60 over 15, again, you can use Desmos for this if you would like, if you're not too good at simplifying fractions, but it actually simplifies to 4. So 4 is equal to k, meaning that b is our answer. And that's it for this question. This is our next question right here. This is a geometry problem, specifically circles. It says in the figure not shown, meaning that we're going to have to draw this ourselves, circle O has a radius of 20. Points A and B lie on the circle such that the measure of central angle AOB is 120 degrees. What is the perimeter of the sector bounded by radii OA, OB, and minor arc AB? So the first thing we're going to do is just draw this out, right? It always helps to draw a diagram with what you're working with, especially if it's, of course, a geometry question. So I'll draw the center of the circle here because it's titled Circle O. That means that the center of the circle is O. And then it says that A and B lie on the circle, so I'll put 2 points A and B. Now I'll just draw in this angle that we can call roughly 120 degrees. It may not be perfectly accurate to what 120 degrees might look like on an actual circle, but for our purposes in this question, that's totally okay, because we're just trying to find the perimeter of this sector right here. So this is the minor arc AB, and as I said, we are tasked with finding the perimeter of this sector. Now let's break down what we have in this problem and what we want. So we know that this slice, quote unquote, if you want to call it that, the slice of the circle is 120 degrees out of the total 360 degrees that are always in a circle. This is, of course, 1/3 of the total circle, right? And so something that's pretty cool about circles is if we have a central angle like this, right, that's formed by these 2 points, A and B, and these form a minor arc, the perimeter of this minor arc is going to be the same portion of the circle's circumference that the central angle is of the circle's total amount of degrees, which is 360. So simply put, the perimeter of AB is going to be 1/3 of the circumference, because the circumference is, of course, the basically the perimeter of this circle, right? So that means we need to find the circumference. So what is the circumference? So the circumference formula is 2 pi r, where r is the radius. The radius is 20, as they told us earlier in the question. So now we can just plug in that radius. This makes 2 pi times 20, which we can simplify to just 40 pi. And so now we can set up a ratio, right? We can say that 1/3 is equal to x over 40 pi. So 1/3 equals x over 40 pi. When we solve for x here, what we're going to get is the length of the minor arc AB. So what this gives us is 40 pi over 3 is equal to x. And we'll rewrite this to just say AB, right? Because x is referring to AB. So we'll just write this down so that it makes more sense to us. So nice, there you go. That's the length of minor arc AB. But remember, we're trying to find the perimeter of the sector. If we draw out the sector, it looks something like this, right? So what we've calculated so far is 40 pi over 3 on this top portion of the sector, but we still have this side over here and this side over here to take into account for our final calculation. But of course, we know that both of these are radii and they are both equal to 20. So if we add this all up, that becomes 40 plus 40 pi over 3 for the total perimeter of the sector. So our answer is A. It's important not to get tripped up here into just calculating the length of the minor arc AB. That's only one step in this problem. You also have to take into account, like I said, those two radii, because whenever you're calculating the perimeter of the sector, if you see this shape that I drew in the top right, that kind of looks like a slice of pizza, you might say, we basically have to take into account these two sides on the left and right of the sector when we're calculating the perimeter, because the perimeter is the total length, right, of all of these sides added together. So we can't just ignore those two sides. We need to add them up to get 40. And then of course we add 40 pi over 3, which is the minor arc AB, to get 40 plus 40 pi over 3. So there you go. A is your answer to this question. All right, now let's move on to this question right here that asks, for how many values of k does the equation x squared plus k minus 4 times x plus k equals 0 have exactly one real solution? So whenever you hear that phrase in a question, one real solution, it should always set off alarms in your head that you need to be using the discriminant. And the discriminant formula is b squared minus 4ac. Recall that if b squared minus 4ac, the discriminant, if it's exactly equal to 0, that means that we have one real solution, right? And of course, the discriminant applies to the standard form of a quadratic, which is ax squared plus bx plus c equals 0. And so again, sort of other problems that we did, we're going to have to identify exactly what our a, b, and c are in this equation. So if we just look at the equation that we're given here, it's pretty obvious to see that our a is equal to 1, right? Because x has no coefficient, which means that there's just an implicit 1 there, of course. And then our b here is going to be k minus 4, and our c is going to be k. So now we can actually use the discriminant formula. If we just plug into b squared minus 4ac, we get k minus 4 squared minus 4 times 1, which you don't necessarily even need to write because anything times 1 is just itself, so we can just ignore that. We don't need to put the a into the formula in this case just because it's equal to 1, right? So it doesn't make a difference. And then times c, of course, which is k. So now that we have this equation, what we basically need to ask is how many values of k can actually satisfy this. So what we're going to do now is head over to Desmos to finish up this question. You could actually re-expand this into another quadratic and then find the discriminant of that quadratic to solve this, but Desmos is going to be a lot easier than that, so we'll just head over to Desmos. All right, so now we're on the College Board version of the Desmos graphing calculator so that we can finish up this question. Remember that the equation we were dealing with was k minus 4 squared minus 4 times k, and that was equal to 0. So what we're actually going to do here, this is a pretty cool Desmos trick. Instead of using regression here, I know a lot of students would like to use regression here, and there probably is a way that you can do that. Regression's problem is that it's only going to give you one solution for your regression parameter. So you can see here, it's only giving me one value of k that makes this true, 1.52786. And so I know that there has to be at least one value of k that can make this true. But the question is asking me how many there are, which implies that there could be 2 or 3 or 4, so on. And so this is not a viable way to solve the problem just using like a simple regression like this. Instead, what we're going to do is we're going to replace the tilde with an equal sign and replace the k's with x's. And that's effectively going to transform this into a function which we can observe graphically. And the reason we're doing this is to see how many solutions it has, right? How many roots it has, or how many x-intercepts it has, you could say, right? There are many different ways to describe the roots of a quadratic equation. x-intercept, solutions, etc. And so you can see here, one of our solutions, 1.52786, that is the solution that Desmos gave us through regression, but it's not the only one that exists. So you have to be very careful when you're using regressions in this sense, because we can see here there is another solution that the regression did not catch, and it's 10.47214. But of course, in this question, we're not super concerned with what the numbers are exactly. We just care to know how many of them exist, right? How many solutions are there to the given equation? If you recall, like how many values of k can make this equation true. If we zoom out here, we can verify, yes, there are only 2, right, in this graph. And so that gives us our answer. There are only 2 values of k that satisfy that equation. So we'll go back over here and we'll circle B. That's our answer. All right, now on to the next problem. It says a right rectangular prism has dimensions 9 by 12 by 15. A plane passes through one vertical edge and the opposite vertical edge. What is the area of the cross section created by the plane? Now, just to clarify, when we say plane, we don't mean some aviation device, right? What we actually mean is sort of like, if you can imagine a 2D object, right? Like a square, a flat sheet, so to speak, passing through this rectangular prism. So let's draw our rectangular prism now. So just start with this face, and this isn't going to be perfect by any means, but should be all right just for our intents and purposes. Cool, so this is our rectangular prism. They tell us that it has dimensions 9 by 12 by 15, and that is our length, width, and height, respectively. So we'll just label that on our rectangular prism. This is 9, this is 12 here, and then this right here is 15. Cool, now a plane passes through one vertical edge and the opposite vertical edge. So we can just circle the 2 vertical edges that are being referenced here. And then we'll draw in our plane. So I'll change the color here to blue because that's a lot easier to see. And it passes through this vertical edge all the way through here to the opposite vertical edge, right? And so what's really helpful here is to draw a top-down view so that you can understand what's going on here a little bit better. So if this is our top-down view, right, this is where the plane is going. So you can see here it forms a triangle, and that's going to be very important later on when determining the length of one of the sides of our plane. Right now, I'm just going to draw in the rest of this plane in this rectangular prism to the best of my ability. I'll shade it in as well so that you can get the idea of what's going on here. This problem is pretty difficult just because of the sheer amount of visualization that you have to do of what's actually going on in the scenario described. But nevertheless, what's basically going on here is the width of our rectangular prism is going to translate over to this side right here of the top-down view. And then our length, 9, is going to translate to this side right here. So now you can see here we have a right triangle with 2 sides and then 1 missing that we need to find because, of course, we're trying to find the area of the cross-section created by the plane, and we have all but 1 side. So that's what we're really doing here is we're just trying to find that remaining side. And the way we do that right now is going to be through the Pythagorean theorem because, of course, we have these 2 sides here to a right triangle and we want to find C over here. So a squared plus b squared equals c squared is the Pythagorean theorem, which most students are familiar with. So we'll just say 9 squared plus 12 squared equals c squared. And then if we evaluate this, that gets us 81 plus 144 equals c squared, which gets us 225 equals c squared, or root 25 is equal to c. And then, of course, if we simplify that, and again, you can use Desmos for this if you don't know the mental math just off the top of your head, but it gets us that c is equal to 15. So now if we take this plane out of the box, so to speak, right, we draw it outside here. Because we now have the lengths of all of our sides of this plane here, we can actually calculate the cross-sectional area of it, right, the length times the width. So we know that these 2 sides here are 15 because that's what we just calculated, right? That's the top portion. I'll highlight it here in yellow. Top portion here of our plane, right? That's what we're labeling as 15. I know there are a lot of colors going on here, but this is all for the sake of your understanding. So these 2 sides down here are calculated as 15. Now recall that the height of the rectangular prism is 15. And in this scenario, the height is actually being shared between the plane and the rectangular prism, right? This edge here is going to be the exact same length. And so we can just bring this 15 over so that becomes 15 on this side and 15 on this side as well. And recall that area is, of course, just length times width. So it's going to be 15 times 15 is equal to the area, or 15 squared, you can call it, right? But either way, that points us towards our answer being B. 225. So there you go.